Okay, back to this other limit. If you try solving it directly by substituting infinity and infinity, you're going to have what? Infinity and infinity that is undefined. And so you're going to try using the L'Hopital's rule that will still give an undefined number, because if we differentiate sin x, we are going to be having cos x. That will be cos x all over 1, and limit of this will tend to infinity. Okay, let's try using a. We are going to be using the squeeze method to solve this limit that is based on inequalities. You know that sin x is ranged from what? -1 less than or equals to sin x, which is less than or equals to 1. Okay, if we divide out through by x, that will be all over x. That will be all over x here, and this all over x. Hence, -1 all over x. Or we can just apply the limit at this point. If you apply the limit here as x tends to infinity, 1 over infinity will be what? 0. And here we apply a limit. Here we are going to be having a 0. Hence, this limit is squeezed between 0 and 0. Since the lower and the upper bound are equal, hence we can conclude that limit as x tends to infinity of sin x all over x is equals to 0. Okay, sorry, here was 0, not 1. I was confusing that with the limit as x tends to 0. I'll be giving 1. Okay, we are going to solve for x tends to 0 in this other video. Take a look at it.